which are higher temperature of the cooling air supply and the lower mechanical fan speed. With that in mind, the total energy consumption of trim amounts to 13 kilowatts. To circumvent the relatively low amount of energy demand, we implemented strategies as sustainable solutions like solar panels, and with a conservative and commercially viable estimate, our solar panels produce 59 kilowatts, while wind turbines produce 54 kilowatts, totaling up to 113 kilowatts. This makes trim a net zero building.
A lot of numbers, huh? So, net zero energy building. Yes, this is good. It's friendly for the environment. But do you know what else is also important for an impactful building? The user experience. So, looking at the design of our module again, we took precedent studies from your typical impression of the PPVC module, an angular, rigid piece, that gives this kind of negative spaces. So we decided to take this up a notch. We will vary the design such that it's still easy to manufacture and it's still pretty angular. But when we combine them together, we can get more organic forms that can actually accommodate the site area of Coney Island. And we can also encapsulate green areas, turn them into exhibition spaces, and maximize the view of the sea. And this is why we have this design of our module. Okay, PG also mentioned earlier that through the wind simulation, most of the wind velocity is concentrated around the auditorium. So, what we decided to do is to capitalize on this and generate more energy for our building by installing wind turbines from the ceilings and on the sides of the auditorium without disrupting the user experience. Virtual reality. We use ArchiCAD software to construct the entire building. And we have a freeform camera that allows us to explore what is it like from the user's perspective. This allows us to curate a very atmospheric experience for the users, being able to enjoy nature while dealing with the stresses of work.
So you now can visualize how trim will look like after it's built. But we can also visualize how trim would be built using Navisworks. So Navisworks not only can help us visualize the building sequence, we can also detect clashes and eliminate clashes across disciplines. For instance, if you look at this picture, there's a clash between the architectural part and the structural part. And if you want to eliminate the clash, you just manually shift the lamppost around. The same for the water piping system, whereby you reroute the system. In cases where rerouting isn't feasible, then Navisworks Manage actually serves as a tool to pre-warn engineers ahead of construction process, so you know the specific location of the area of conflict. Next up, we use Trimble Connect, which is an online collaborative platform which allows us to upload our Revit file. So our members don't have to download the Revit file and reopen it on their computer. It actually runs smoother on lower rank computers than on your Revit software. Next up, Trimble Connect also allows us to circle out the area that we want changes to be made. So our members are constantly updated of the changes that they have to make.
So one of the challenges that we faced in building trim is the placement of solar panels. On one hand, we want to generate the most amount of solar energy. On the other hand, the architects felt that it would affect the aesthetic of the building to place the solar panels on the rooftop garden. So what do we do to solve this issue? We inserted a line of greenery to demarcate a clear area for M&E services while retaining the environmental aesthetic. So in this way, we can harness the greatest amount of solar energy, and at the same time, millennials would not notice the M&E services. From this competition, we learned that it is okay to not know everything because you have a team with you, and it's only through a team where you can accomplish things far greater than you can imagine. Looking ahead, we are all really excited to to continue to build our skills in the build industry, and we are also looking forward to contribute to the industry in the future. And genuinely, from the bottom of our hearts, we are very thankful to BCA, and we are very thankful to Singapore Poly also for allowing us to be part of this competition. Thank you. So I'm not sure if time permits, but we actually have a video that showcases the form and function of the building, but we didn't put it on the slides because we realized that it may not be. It's 4 minutes. I mean, it's up to you. It's just okay, but I might need some time to find it on the Google Drive. Okay, sure.
Yes. Actually, I'm not sure about the speed because we didn't take that into consideration. But what we considered is instead the land area required for the wind turbines, because generally wind turbines they take up a lot of land area. So vertical wind turbine actually maximize the energy per land area needed, and it's also considered bird friendly as well as monkey friendly. So that was our main consideration when implementing wind turbines.
Just a second, don't play the video first. Yeah, let's finish this section.
Okay, but because we got wind simulation, so this shows that there is sufficient wind especially at the roof of the building. So the wind turbine will operate.
I follow with the comment first. Your net zero energy calculation needs to be relooked at.
Okay, yeah,
It needs to be relooked at, okay?
right.
Mainly the assumption that of firstly your possible generation.
Okay.
You generated on the dot, like 113 versus 113.
Well, it's because we calculated the cooling load first. After that, then we added a minimal amount of solar panels or the wind turbine is to maintain both aesthetics as well as the energy production.
The solar slide. In general, the way that you are doing this is more or less correct. More or less correct. But there are things that you need to take into consideration. Solar panels degrade every year. So you build this building next year, it's no longer zero energy. That's one. Then then the thing about the vertical mill, right? You really need to look at it, get more data, get more research on the thing. So I'm not going to comment on the first part of the power consumption part, because I'm not an engineer. But it looks a bit optimistic, if I can use the word. It's a bit optimistic. But I'm no engineer, but I've seen enough calculations from my engineering friends that did the calculation, and the next year, it's a bit off. But yeah, well, this like the overall way, A plus B plus C plus D is generally correct, but it's just a little bit off. You really need to look, and there are a lot of data available. Look at SPE for calculation. Ask the prof for it. So it's there. Okay. Then US, right? Yeah. US, right? Yeah. So look at SPE for the calculations are there. From the planning point of view and your wind simulation, you all had, can I look at the picture where you have this big where you all need to do your plaza auditorium area, right? Did you all consider rain switching? It's good to have wind when there's wind, but when it rains, your whole place is not going to be usable. Because you have a very, very high wind, and that is meant to be a space to be used quite often. You want people to enjoy it. So it's quite. Of course, we are highlighting the point that we feel that is strengthened. There's a lot of merit in the scheme, but we just want to highlight because of time. So we don't say, hey, very good, but then we want to highlight things that could be.
Okay, thanks, Mr. B. Yeah, so, okay, perhaps it's not very clear here, but we showed the auditorium in all its glory. But we actually have a screen that can lower down to protect from the rain. And it can also be used as a projection. So you can project your slides onto the big screen for everyone in the auditorium.
Not sure, not so good that you are having considered.
So do we have time for the
One other, do you have a floor plan to show the actual floor plan, not the sketches of your module? Because, and the other question, one module, you only have one module type. One module type. Two. But it's one now. Mirror, we are being generous. Technically it's one now. Technically it's one. Technically it's two. It's two. Okay.
Because we want to reduce the number of types of modules.
I'm just looking at your actual sheet. You have one sheet. Then what are the limitations that you have here? This is CAD. I'm just really interested because I also want to adopt. Right? It's very ambitious to have one module and you can do 10,000 at one thing. Yeah. But these are all sketches. So, for example,
The picture and
I
the
understand this two is the same module. This two is the same module.
so it's like a module but with 3 sides. So you have 3 sides and 3 sides, then merge into a block.
Because what is a trapezoid shape? The other
My point is that
yeah, it cannot be that because let's say, for example, if this is a trapezoid shape, therefore it's got a pointy corner. How does this guy basically integrate the trapezoid?
It's actually like we cannot have two modules, so when we stack both together, it's actually a rectangle. It's just like the other one on the truck.
I'm talking about the two ones on the lower level. So
this is one module, right? Then
Yes.
this is the module, right?
Yes.
So technically, this side of this module is slanted, right?
Actually, our this sketch is incorrect, but it should be the one on the truck.
Which is why I wanted to see your CAD drawing. Go down. You have a CAD drawing below, right?
Yes.
Yeah. Are these CAD drawings?
Yes.
So I'm just thinking, how do we form that shape that you had earlier?
Yes, you're right. The drawing is a bit incorrect because there's a concept design. But this shows how the modules will interact together. So we get a very arc kind of formation. And this allows us to circle around the trees. So we touch the ground lightly. We build around the trees that are already there. Yeah. And you want to have more like thicker spaces. You see on the right, we have this sort of like meeting rooms. Yeah, where the modules can combine in a different manner.
Any other questions before we go to the video?
So for the simulation of the building process, right, we use Navisworks Manage. But when Navisworks Manage and Microsoft Project can work together, so I can import the Microsoft Project into Navisworks, and then I just link certain parts to the 3D drawing, and then when I play the process, it will just build layer by layer. Yeah. So
our architectural part is done in ArchiCAD, but when we did with Revit, we did Revit for the MEP stuff. So what we did was we used ArchiCAD, we merged it, we imported it as an IFC file, so that Revit can open the IFC file. And using that, we can use the MEP elements of Revit.
yeah, actually, I was just gonna ask about how does the DHME tool work. So it looks like you have this kind of organically shaped, like a stingray shaped with voids kind of floor plate, and you basically place the PPVC components on it. Is that how it works?
So the only thing that is not really PPVC is the roof, which is what kind of gives the stingray structure. And so you see the voids on the roof. These are actually trees. The voids are for trees to go through. So within the building itself, there'll be trees growing within the building.
Yeah, but you see this, for example, the drawing on the left side, this one, this is a first story plan, is it? Or which one is the first story plan?
This is the first story plan.
So, but you already have this profile, basically, and then you basically, if you take a look at the perspectives, you actually need for these PPVC components to basically sit on top of them, so you can basically walk around them and have these areas as lounges and kind of like balcony spaces, all of these kind of in-between spaces. So in effect, it's like my reading of the structure is that you basically have a series of these slabs at different levels. They're very organically shaped, and then you basically place the PPVC on top of it. Is that how it works?
Yes.
Then can I take it to say that this organically shaped slab thing is not is a conventional, will be a casting structure? Would that be correct to say?
Yes, correct.
And it happens at every level. How many floors?
We have 5 floors. So the entire building is using PPVC. So what we do is we make use of our building is made completely out of PPVC, and all the negative spaces, right? Like the places where there's